Alright guys, here we go. So these are your video lecture notes for relative humidity. You will find the PDF, or you may use the printed out version if you've got it to complete these notes in the Canvas section, or if you've got your notebook, you're welcome to do it there as well. Either way, make sure you turn it in. Note, if you're doing the electronic version, take a screenshot of your completed sheet instead of turning in the file directly. I'm finding that Canvas is submitting blank documents instead of your completed notes. So take that screenshot so that I know that you've completed your notes. This is our bell ringer, just a thought to begin our lecture. What does it mean to have humid conditions? So if I say that it's very humid outside, what does it feel like? We're going to discover kind of how we measure humidity, relative humidity specifically, and what that means for our weather conditions. Here's where our notes start. So relative humidity is defined as the amount of moisture in the air compared to what the air can hold at that temperature. So there is a threshold of a water vapor that can be accumulated in the air. When we reach 100% humidity, that means that we are holding as much water as possible. There's as much water vapor as possible in the air at that time before it rains. So that is why it is generally very humid before it rains. If we're having very dry conditions, that means that there's not that much water vapor in the air. That's relative humidity. We use a psychrometer to measure relative humidity. Now, the traditional measurement is a sling psychrometer, and basically it's a cloth wick on a thermometer. So this is the wet bulb. It's a wick that is wet or dampened, and you put it on a thermometer. And then it has a second thermometer that's just exposed to the air like any other thermometer. So our definition here, the clock, or how it works, the cloth wick is saturated in water, and the instrument is whirled like this, like a lasso, around in the air. The water evaporates from the wick, cooling the wet bulb temperature. So generally our wet bulb, if it is going to change, it will be lower than our dry bulb temperature. Both of the temperatures are compared, and the difference is how we calculate our relative humidity. We're going to practice this and see maybe what that means as well. Here's an example of what an actual sling psychrometer looks like. Again, it's just two thermometers. One of them has a wick over it that you dampen before you whirl it around in the air. And then you compare the two temperatures to figure out relative humidity. Now, because technology has advanced, we've got handy dandy readers like this that will actually calculate the relative humidity for you. No math involved, but what kind of fun is that? We want to be able to calculate relative humidity, so we're going to learn how. Again, we're going to compare the difference between our wet bulb and our dry bulb temperature. We have found out through studying that if there is a greater difference between the wet bulb temperature and the dry bulb temperature, that means that there's more evaporation in the air, meaning that more evaporation has happened, meaning that the air is very, very dry. Now, in contrast, if I am whirling around my sling psychrometer and I have a very little difference between the wet bulb temperature and the dry bulb temperature, that means that there is less evaporation, there's less space in the air for my water molecules to evaporate. That means it's very humid. So I've got a little test your knowledge question for you. Which one is more humid if I were to get these differences? So if the difference between my wet bulb temperature and dry bulb is 5 versus 2, which one is more humid? You will find out that the less difference, remember, means that there's less evaporation, meaning that there's more humid air. So 2 would be our winner here. This one would be more humid than a wet bulb, dry bulb difference of 5. So here's how this actually works. We're going to calculate this, like I said, because we want to be able to interpret scientific results. So here's our steps in interpretation. So we're going to pretend that I have just slung a psychrometer around in the air and determined my dry air temperature. So maybe my air temperature, like in this example right here, is 28 degrees Celsius. Step 2 now is to determine the wet bulb temperature. And that's again just by swinging my psychrometer around, I will be able to find both dry and wet bulb temperature. My dry bulb temperature is 28 degrees Celsius. My wet bulb temperature here was 25 degrees Celsius. Fantastic. Now I've got a little bit of math to do. It's subtraction, so this shouldn't be hard for us. But you're going to plug the temperatures into the following formula. Our formula for our wet bulb depression is dry bulb temperature minus wet bulb temperature. So for example, my dry bulb temperature here is 28 and my wet bulb temperature is 25. So I am going to take 28 degrees. Maybe let's do it like this so you can see some math here. So I would take my 28 degrees, which is my dry bulb temperature, minus my 25 degrees, and that is going to give us a wet bulb depression of 3. Now, to calculate my relative humidity, I need to go one step further and compare my dry bulb temperature with my wet bulb depression to get the relative humidity. So my wet bulb depression is 3, so we're going to go in this column. And then my temperature is 28 degrees Celsius, so we need our dry bulb temperature. And we trace the two to where they meet, which is right here. And that is our relative humidity. So in this case, our relative humidity is 76%. Okay, so you use the wet bulb depression and dry bulb temperature to determine relative humidity. You compare the two. You need this graph, otherwise you can't do it, or a graph like it. I've got a larger one right here for your practice problems. But you need the two in order to determine your relative humidity and the chart. Okay, so you use that chart to figure out your answer. Let's do the other practice problem right here. So the air has a relative humidity of 92%. So we know that our relative humidity is 92%. And we want to find the wet bulb temperature if the air is 30 degrees Celsius. So now for this one, we're going to have to identify where 92 and 30 degrees Celsius match on our graph right here. So we go to 30 degrees Celsius and you're going to scan to the right until you find 92, which is right here. And then we're going to go up and see what our wet bulb depression is, which is 1. We figured this out by looking at the graph. And then we know, based on our formula, that it is dry bulb temp, which we said was 30, minus our wet bulb temp equals our depression, which is 1. So in order to figure out our wet bulb temperature, we need to subtract or add the wet bulb to get it over on this side. We're doing a little bit of algebra here. So you would add the wet bulb temp, which is a variable. So we're going to change this to variable W. You would add it to both sides so that we can isolate it. And now we still need to isolate it, so we're going to subtract 1 from each side. Those ones are going to cancel out, so we can delete them. And then we do the math equation, the math problem right here. 30 minus 1 is 29. So 29 degrees is our wet bulb temperature. All right, so that's how you calculate it, and I'm going to ask you in the next slides to calculate 3 additional problems on the bottom of your sheet. So here is what you're going to use as far as your graph for calculating. So after you found your wet bulb depression, you take your actual temperature and find the wet bulb depression, and you see where they meet. So you're going to need to come back to right here when you're doing your practice problems to figure them out. You're going to have to pause it and come back. Now pause it and come back. You're going to have to come back after you've paused it and written down your questions here. But here's the 3 questions I would like you to write on the bottom of your notes. Try to work these out. I'll check them to see if you've got what's going on. These aren't going to be graded for credit, but I want you to try so that I know if you understand this concept. Okay, you've got 3 problems. They vary in difficulty going down. So this one is pretty easy. You just plug it into the equation and use the chart. This one is a little bit more difficult. And this one is the hardest still. Okay? So again, you're going to need to use this. Pause the video on that when you're ready to try and compare. Have a great day, guys.